Show that two composite functions are equal. So in our example, we are going to take and find if f of x equals 2x minus 5 and g of x equals 1/2 times x plus 5, we want to show that f composed with g of x is equal to g composed of f of x. So what we're looking for is that every x in the domain of f composed with g and g composed of with f are the same. So first we're going to look at f composed with g, and we're going to take and put in 1/2 x plus 5 for g of x, and I just put the half below it to make it easier. And then we are going to replace that in our equation where the x is for f of x, and we end up with the answer of x. So now if we look at g composed with f of x, this time for f of x, we're going to put in 2x minus 5, and then take that 2x minus 5 and put it in for the x in the g of x equation. And we will then end up with 2x minus 5 plus 5 all over 2. The 5's cancel out, and I'm left with 2x over 2, which leaves me with x. And you will notice that f composed with g and g composed with f both equal x. So what that tells me is that therefore f composed with g of x equals g composed with f of x, and they all equal x, so they all equal the same thing. Alright, so finding the components of a composite function. So this time we're going the opposite direction. We already know what the composite function is, but we want to find the components that make it up. So first off, looking at h of x equals 3x squared minus 5 to the 21st power, I first looked and noted that I could use this 3x squared plus 5 as one function and then replace that in f of x with an x. So I took that 3x squared minus 5 and let that equal g of x. And that's in the middle of the function, so that we want that to be the second part of our composition, f composed with g. So that means we want g to be inside of f. So by taking that out and replacing that 3x squared minus 5 with an x, I end up with the functions g of x equals 3x squared minus 5 and f of x equals x to the 21st power. So now we want to verify that we are correct. So we want to know that f composed with g of x equals f of g of x. I'm going to take my g of x and put it in my f of x function. And then when I solve it, I end up with 3x squared minus 5 to the 21st power. And that matches our h of x equation. So let's look at another example of that. Find functions f and g such that f composed with g equals h if h of x equals 1 over x plus 1. So right off the bat, I see that x plus 1 would be easy to replace and use that as a separate function, g of x. So we're going to let x plus 1 be g of x because that is in the second position, and we're going to replace that with just x in the f of x function. And to verify that this truly works, we're going to place it into the f composed with g of x equals f of g of x. So that means we're going to be now solving for f of x plus 1. Put that in our equation, and you will notice that our h of x matches. So our composite pieces that we used to make up the composite function h of x are correct.